walk through with a little bit of exercises about code reviews and what we can do to secure code. So let's get going here. The code reviews are fundamental for us to discover any security flaws within software security. So we have 3 types of code reviews we can perform. We have the formal kind of code review where we sit down and agree in a formal forum about what should happen in the code and what is going on in the code here and how secure is it and is there any flaws or bugs. We also have a rubber duck method that we can simulate that we are potentially talking with somebody about the code while we are writing it or while we're reviewing it. The type 2 is where we do some pair programming, so we have a navigator and a driver, and this will help us in order to produce secure code. We have also the peer code reviews where we can use Git to set up the code, and then somebody will peer review that through the GitHub or any other tools. And this was widely used in larger companies. Type 3 is about we will send it out for an external code audit. That's a potential good way to secure code and unbias yourself, because you will often stuck in a bubble of what the code actually does. So that is a very legit method of securing code. And we also have these automated code reviews where we enhance or use tools that will allow us to perform some detailed inspection of the code based on some signatures that are common code flaws, but you'll have always to review them because they can also be flawed and with false positives. So what we also should be sure that we are, while we are doing code or code reviews, we should always be doing it before the commit, we should be doing it after a commit, and we should also be when the code has been executed or launched, we should also ensure that we have the post-mortem code. And what happened also when we discover something or we have some kind of flaw. So let's go on, and then let's look some coding guidelines from the big players here. We have the OWASP, they have a code guidelines. We also have Mozilla secure coding practice, and we also have further ways you could explore some good coding practice online tools. So what is also important that we should avoid some mistakes, and that is to not review old code, and we should also not just fully rely on automated code reviews. So what is actually the threats here, and what are we trying to avoid? We are trying to avoid some zero-day attacks. We have some very bad example of that later on here. So, but let's get the basics going first. So let's look at a zero-day exploit is something that is, here's the timeline. So we're looking at a vulnerability that is introduced some way nobody knows and nobody has an idea of what is happening. This is a 0-day. So the 0-day vulnerability is introduced. The vulnerability is then discovered either by the company itself who made it, or somebody else. Often it's somebody else who's not disclosing it, but eventually the 0-day would be disclosed. So, and then we need some kind of vendor to who develops a fix. That is the vendor of the software, and they will come up with a fix. They release this patch, advise everybody to patch it. This is important that we are aware of if we are responsible of some kind of code that we are patching the correct code, and we also our devices are patched when 0 days are discovered, because 0 days are really serious backdoors, and the patch deployment and is completed and verified that it worked and that it is not an exploit anymore. So we have a serious case here of the Heartbleed. It's a log4j serious attack that exposed a flaw in systems adopted worldwide in many big companies. So this was something about the OpenSSL library. It's something in the C code that was the issue here, so C code, and then there was happening some kind of buffer overread, and this exposed a function that is called the Heartbeat, where it sends a 1 kilobyte heartbeat to a server, and then the server resends 1 kilo plus 30 the remaining here of total of 64 kilobyte. So it will send then it will accompany this 1 kilobyte with 63 kilobytes from the server memory. That is legit code that is exposing what is in the server and server memories, so the stack. So let's just look at it here. the way that it looks. So we have the server, so one setting a heartbeat to say it's alive, this is going on, and the server receives this heartbeat, resends that it's accepted with this additional kilobytes, and then it goes back to the server telling it is registered as being alive. So if we split this up, look at the anatomy of this heartbeat. So the heartbeat consists here, let's look at it more visually, of this 1 kilobyte. This represents our kilobyte sending from our server. So our server sends this to the external server with the log4j. The external server then adds the rest, so these 63 kilobytes, and then the full heartbeat comes back. So these is 64 kilobytes and come back to our server. So now our server received the rest of this total 64 kilobyte, and what it meant for the log4j is that it actually exposed what was on the server here. So this could be names, etc. So also we have the Apple iOS 17 case where we have this go to fail, where there's something in there. There's verification of the encryption keys, the RSA Diffie-Hellman, where it suddenly has go to fail twice, and this go to fail will eventually prevent the code from actually verifying the algorithm, and thereby introducing a major flaw. So in general, we could, from our discoveries, we will say that in general, we say that in 80% of all 80% of all bugs are found in 20% of the code. So there's specific these 20% of the code having to do with 80% of the code. So 80% of all the other code has perhaps very little flaws. So what we can also use is a very effective tool here, a very cheap tool. So grep is a command in the bash line, or the terminal command line. So it is very low cost and effective, and we use it together with a word list. So scanning through a repository, scanning through these words as change mod and fopen. It's a very could be very invasive strings that are represented in the code base here. So here's a little bit more automated, where we see that we can use bash scripting to automate this process, and this is a very cheap tool because this is pre-built in Linux, free way of scanning code. So we also have the proprietary tool. This is a business for itself, static code analysis tools, as told in the beginning. So we can use cloud tools here that will help us support and automate the process here from GitHub directly. You can scan the tools. What is important when you do this is that you ensure that you're comfortable with this and you test it out before you implement this static code tools, because there are very certain parameters that you should be looking at: the usability, false positives, the ways that it integrates and that it's suited for you and you want to use it. There are quite different kind of vendors in this space. So, and then as I said, false positives, you have to verify that. You have to understand that when you use these automated tools, because it can flag something. It doesn't know everything, so it will flag something, but you should verify that this is not a false positive. And false positives are when you have a false negative. You have something that it says that is bad, but actually it is not what it is. So you have something that, well, this says, oh no, here's an error, here's something that is wrong, but actually when you look at it, it's meant to be that way. And that is the risk of using these automated static code analysis tools. And you should also look for the limitations. What do I get? What do I not get in these code tools here? And try to find what is best suited for you. And very importantly, you look at the metrics. What are the metrics? Are the metrics useful for you? And develop some metrics and keep track of the metrics that are reported using these code tools. So static code analysis tools. So SonarQube is one of the leading ones that are presented in the market here. So they have a very effective way of integrating using cloud also. So here are all the for example, the coding languages that are supported by the static code analysis tool: Java, Python, C++, Swift, COBOL, etc., PL, SQL. So there are some big coding languages, but we can see that it's not perhaps every coding language that are represented here. So we could have there are some functional programming languages here that I don't see, F#, for example. So we could not use it for that. So that's important to remember, and making the right decision about which tool to use that are based on your needs as the business. So and the Sonar Cube is cloud-based. Now I'm going to go through the cloud-based example here, where we see that when you are in the cloud UI, you sign up, you have this free version when you get started, or you pay for it, but you select here in the right corner, you select that you want to create a new project. When the project opens, you find your repository. Here's one that is synced. I've synced with GitHub, so I have the Let's Be Bad Guys. This is a cybersecurity trial thing, and we select the repository, and then we create the project here from a previous version. We select this configuration. Now you will just wait. They are analyzing the project, and then finally you get this report that says that we have 9 open issues. This is security. We have 115 reliability, and we have 378 in maintainability that they recommend that we look at. So you can go in, dig deeper on that. So thank you very much for watching. I hope this video was useful for you. Remember to keep you still updated with this channel, and try to, if you thought positive about this or negative about this, react in some way or write a comment what you liked about this. So thank you very much. I hope this was useful.